just wanted to do a video to take a closer look at a few of the things at the front end of the system, in case you're wondering about that details. The other thing is that the silt, on my first video you may remember that I had water trickling into the beginning of the pipe. Well, that's gone now, and I've put the pipe directly in, because what I found is that over time the bottom of the mulch column, it sends silt through the system, and you get a layer of silt building up over time, and it gets very thick. This silt in here is like a good 5 inches deep, and notice my hand comes out clean. Like when I put my hand in the silt, it doesn't stick. It's not oily, it's just ordinary silt. And I've got a micronic mesh, stainless steel micronic mesh here holding everything back, and I found that this silt layer actually forms a very good filter. It starts to turn into a filter, and the water coming down, it percolates very slowly through that raised filtered silt bed, because the whole trough is on a slight tilt. I've positioned it so that it's got a gradient, so you can see that it's going down slightly, so that the water from the kitchen goes through the mulch column here, falls freely because it's sitting on a raised kind of mesh platform, and it falls out the bottom there freely and flows by gravity through this silt bed, which builds up, and the plants love it. Like, this is an African lily here, and a maidenhair, and other reeds and things that really enjoy that. Unfortunately, something fell on my plastic, and now the lily is grown out through the hole. I'll have to repair that. So that's a self-regulating thing, accident that kind of happened. Eventually you'd have to take all that silt out. You'd have to dig it out if it built up too much, but you might even be able to grow orchids in there. Orchids love that kind of thing. And no oil at all, because the oil is trapped. It gets stopped by the very top of that cocoa fiber layer. It gets stopped right up here, so there's no oil in the system at all. I'll just show you a few other things. So this is the core block, core mulch, and it's a compressed coconut fiber. So I'm going to put that in the water. Let it expand. This is what it looks like after the core block expands. It's pushed the bricks aside, and now I can use that in my mulch column. So this modified plastic drum, which holds the mulch in my system, is actually one of these drums originally. And what I did, there's actually a moulding seam there that I ran the jigsaw down there, and I pulled the drum in order to make the thing the same diameter as the lid, because the lid is a bit narrower than the body of the drum. So when I pulled it in, this lid will fit neatly in there, and that's where my my pipe from the kitchen sink goes into there. And I put handles on here so that for maintenance purposes I can easily lift the drum out for maintenance. So I've had to do a bit of maintenance on my system. It sprung a leak in the ferro cement trough I had a cradle here. This is a metal cradle, and before I didn't have these cushions, and the feet actually wore a hole in one spot, and I had to repair it, had to re-bitumen that hole, and I put the cradle back in. I got a piece of plastic lattice, and my drum here, this thing here that I just showed you, was modified from a 200 litre drum. Sits on that mesh so that when you put your mulch in, it doesn't fall through. So in my early attempts at making the system work, I had the blue mulch column there directly on the bottom of the trough, and what happened was that the mulch at the very bottom of the column was wet for long periods of time, and so it became kind of soggy and developed some odor. So what I did is I lifted it off the bottom with that cradle, and that allows air to circulate through the whole mulch column and prevents the very bottom of the column from becoming soggy and causing a problem. So that cradle solved that problem. This next section is the pipe. My system is actually classed as an above ground constructed wetland. Other systems have them running in the ground, but because our block has got a slight slope on it, I've taken advantage of that slope, and this pipe hanging on the fence is hanging on some store-bought brackets that have been curved around to hold the round pipe. It's a 6-inch PVC pipe with holes cut in the top with a jigsaw to let, in my first system I had reeds actually in those holes. You saw them in the first video. I changed that because the root system of the reeds is very dense, and it actually blocked the pipe up. It kept growing and growing, getting more and more dense, and had the pipe overflowing in parts. So I ended up pulling those out and trying a number of other plants, and the pennyworts worked out the best. As you'll see, they have a lightweight root system made of hollow, kind of straw-like roots, which don't weigh much to pull the pipe down, make the pipe sag in between the holding points, the brackets. So they worked out better all around, and I'll just so this pipe comes out of that ferrocement L-shaped trough at the front. This is the next part of the system. These pennyworts, you can just take a normal knife and trim them off like that, and that makes great compost. Or you could lift the whole section of the roots out and cut them off there, like that, and here as well. And that goes in the compost, and the roots are, I don't know if you can see that, but the roots are very straw-like. They're actually hollow, and there's a couple advantages. One is they don't weigh much, so it doesn't drag the pipe down too much. The other thing is they're very water efficient with these waxy leaves. These pennyworts don't use much water, but do a good job of cleaning it as well, and the roots are not as dense, so the pipe doesn't block up as easily as when I had those reeds in there. These are nice kind of coarse roots which let the water through without letting it go through too fast. My little solar setup is just a little trolley, hand trolley with a little panel. It's about a 70 centimeter panel, 70 by 25 or something like that. This has been operating for about 6 years, and this chemo
chemo regulator, I can recommend that one. It's operated faultlessly for more than 5 years. You can see a little amber light on there which indicates that it's charging. So that's a good brand. So that's that little bit, and just a standard car battery. Yeah, it's enough to power my pump. You may remember from my first video I showed you this pump had a built-in float switch which I've deactivated, and I've used a separate switch because of the maybe you can see this brown tinge is kind of like algae, very micro debris getting in there and gumming up the float switch. So now I've got a separate one. It's actually a cricket there if you can see it. That's just about to turn on, so when that comes up, that turns on, and by this green hose there that pumps it up into the storage tank. This is the end of the system here, and the water in here, it flows down here by gravity. We're a bit fortunate because we have a slight slope on our block. I've had to put a metal clamp here to help weigh it down, because of the build-up of that debris, micro debris. I've had to put a weight on there to make it switch off a bit more positively. Once it stayed on, when I was just using this one, it stayed on and flattened the battery in my little solar setup here. I'll just show you something else too. So that little battery pack with the solar panel, that goes this switch here which turns on my pump. This is just a standard bilge pump. But what I wanted to show you was, I'll just turn it on and show you the water flow. Make sure I turn it on. So there we go. That's with the pump on, and that's with the pump off because of the head in the tank. So what I wanted to show you is, just by chance, this fits by chance exactly. When you take the blue cage off the pump, it comes with a blue cage on the bottom there, there's the impeller. It just happens to fit very snugly in a standard 50mm elbow without the need for any kind of sealant, anything like that, which was quite handy. So, and it's an 18mm outlet, which I find gives it a good flow rate, 750 gallons per hour. And there's not much load on the pump because of the pressure behind it. They last quite a long time in that situation. So I'm doing this one-handed, but when I've turned the tap on, so the pump is not on, this is just gravity. The tank, the marker for the tank is about here, so it's about a bit over a third full, about a meter of head behind that. So that's what it looks like, just gravity. If I turn the pump on, then it becomes like that, and that's quite fine for watering the garden. That's really quite good. So that little pump there can do that. There's a little bit of pressure behind it. There's the bananas. Happy bananas. In this section, I'm going to be talking about this kind of system brings awareness to what's going down the drain. So you've got oil, basically oil, food scraps, and detergent. And to give the system an easier time, you want to minimize the amount of oil you can put down the drain. So we use a lot of olive oil in our cooking, one idea is to use paper towels to wipe your plates before you wash them. And for food scraps, you can use a strainer to prevent food scraps going down. And detergent, use a biodegradable, grey water and septic safe kind of detergent. Although from experience, this kind of system can handle those pretty well. This sink's about 10 litres capacity. So what happens if you let it out all at once? Well, you've got to design it in such a way that it trickles the water out into the pipe. That's the main bit. So you've got to have some way of slowing down the flow of water. You could use a surge tank, which is what I tried originally, but what I found is the tap, or the little hole coming out of the surge tank, gums up because the water's coming straight out of the sink into a container, and you're metering it out with a tap. That tap will gum up with like a soapy, oily kind of substance. So that's why I went to the open mulch column. And that ferrous cement trough at the front serves as a surge tank because of the micronic mesh, and the silt slows the water flow down into the pipe. So, what happens if you go away on vacation, for example? Well, obviously, if there's no water going down, the plants in your pipe, in that pipe there, are going to dry out and start going yellow. So that's just something to think about as well. I'd like to talk about the concept of dwell time. When you're designing your system, this concept called dwell time, and I'll use a little whiteboard for that. Okay, thanks. So just before I prepare my whiteboard to talk about dwell time, I've had this, just drag the whiteboard out, and some time ago I wrote down some of the things I value, I've got healthfulness and usefulness and health, and I've got trees, nature, flowers, creativity, connecting, competence, contribution, principles, truth, belonging, kinship, community, ideas, quality, wonder and beauty. And maybe that's just a little few seconds there that, that's like if what you value kind of defines your character, then these are some of the things I value. So I was just trying to clarify it in my own mind for myself. So now I'm going to wipe all that off and talk about dwell time. So I hope you'll excuse this scattergun approach. So this just explaining it in a very low-tech kind of way. But because of my technical background, my system is kind of extensive, but yours can be much simpler. The simpler, the better, and just a point to use the least number of gadgets like pumps and electrical devices to keep it simple. So this is basically the sink through a diverter valve. This is in through the mulch column into a trough full of plants, and the trough has a slope on it through that filter pipe and through a sandbox into that first large tank with the circulation pump in it. Then it overflows into 4 drums that are connected. These are 200 litre plastic drums. That overflows into the lowest point, and when the water fills up from the bottom, the little float switch turns on and pumps it into the storage tank. So that's that's your system. I know this seems like overboard, but your system, you'd use whatever elements. This is why I wanted to talk about dwell time. But when I say dwell time, it refers to the amount of time that the water in the system spends around the roots of the plants, because it's the roots of the plants, the high surface area of the roots do the work of cleaning the water. And my original system had gravel in it, because this system here is about my 5th attempt at getting it to work. Originally I had gravel in barrels, and the problem with gravel is it's expensive, it's heavy, it's hard to work with. The plants take a long time to grow in gravel, and they have trouble growing in gravel, and the gravel takes up a lot of volume without, in my opinion, without offering very much. So that's why I've gone to a system based on root volume, because it's those fine high surface area of the roots. And I showed you a few photos in all the experiments. I put plants in a plastic barrel and just put them in the sun. That's another thing, that it's very important to put the plants in the sun, because they do a much better job of cleaning the water. And the roots grew to the shape of the barrel, like in this photo here. I can show you that the root mass is well on the way to filling out that barrel, as long as you've got the plants in full sun. And you could have a system, in theory, you could have a system that is just barrels in the sun, because in my system these barrels were in the shade, so they're not working as hard as they could. So dwell time, you want to aim for a dwell time of 3 to 4 days around the roots of the plants. So you want the water to hang around the roots of the plants for 3 to 4 days. That's what I mean by dwell time. So that means kind of like 3 to 4 days of dwelling around the root masses. So, for example, it all depends on output. So, if your output is, say, 50 liters from your sink, so you 50 liters goes down there, then and then times, just say 4 days, times 50 liters is 200 liters. So when you're designing your system, you'd want about 200 liters of root volume of your plants. So that's going to take time to develop, but in theory, like I said before, you could fill out one of these drums. The root mass can grow to fill up almost the entire area of the drum, and you could achieve that dwell time with just one barrel full of root mass. You could do it that way, for example. So I'm just looking at my notes here. Dwell time of 3 to 4 days around the plant roots. You want the plant roots provide high surface area that does the work. Plants work better in the sun, and when they're growing, they also work better when they're growing. So you want to trim the plants, everywhere. Trim them off, with a pair of scissors or something, so that they can grow again. Because when they're growing, they do a better job of cleaning as well. So, what else did I want to say? So, yeah, you can do your own thing with this. So basically, it's a factor of 4. The important thing. This is just my idea that I've come up with. So it's basically 4 times whatever your output is from your sink, and that's the root volume. That's the plant roots volume that you want to establish in order to filter that water, to clean that water good enough to use on the garden. And I've got a hose connected to my main storage, which I use on the garden. The plants have been growing fantastically on that water, so there's no problem with it. In these tanks, you can put fish in here if you want to. Just put a few fishies there, and you could turn it into an aquaponics setup if you wanted. It's up to your imagination, but this is just my idea of 4 times the output in root volume, so you might have to experiment a bit, but just max it out, like get some reeds and some barrels and experiment to see how much root volume you can get happening. And you could have a system that is just a mulch column going straight into one of these barrels. You could do it that way. It might take time to establish, and you could let it go on trees. Probably that would be alright. So that's so the important thing is the 4 times is the output is the root volume you want to design into your system, whatever it is. I could talk about all my first attempts at doing something, and I do have photos of my early attempts with gravel and with early attempts at a ferrous cement trough, and I made a lot of errors. But you can start with a very small system. It can be as simple as the mulch column is very important. I don't think you can do without that. And you could have a pipe if you've got the room. It all depends on your setup. And going into a few of these barrels connected. I've got them connected by a fitting. It doesn't have to be that extensive. You could have just those 3 elements: the mulch column, a bit of a pipe, and maybe a couple of barrels full of plants in the sun. You gotta make sure that they're in. That's very important. So I'll just emphasize that, because the sun does the work, and the plants do the work too. That forms an amazing filter. It just grows and grows. So I hope that's, excuse this chaotic approach on the whiteboard, but that's basically something to think about in order to get going and keep it simple. And thank you for listening, and I hope I've included some useful information. And if you have any questions, you can just write them below, and I might talk about my attempts at the earlier designs that failed. I could probably talk about those in another video, but I enjoyed making this video. Thank you for letting me share what I've been doing, and I wish you all the best, and take care. Bye.